Okay, my friends, so now we're about to have a very exciting tutorial because we're about to watch the demo. The demo of our AI being built first, then trained, and finally making our single predictions. So this is where we left off in the previous tutorial. Basically, all the implementation is done, and now I'm gonna guide you through how to run this on Jupyter Notebook, and therefore the first thing I'll do will be to download and install everything we need to have Jupyter Notebook. If you already installed Anaconda, which contains Jupyter Notebook, and if you already have Jupyter Notebook on your machine, then feel free to skip the 5 first minutes of this tutorial and start directly from minute 5, okay? This is when we will start using Jupyter Notebook. And for the rest of you, well, follow me. I will guide you through the installation of Anaconda and therefore Jupyter Notebook. So let's open a new search tab on your favorite browser, and in the search bar, let's type Anaconda. There we go. So Anaconda, then we're gonna go to the first link. Anaconda has become so popular now, and we're gonna go to, well, get started and install Anaconda Individual Edition. Then you can click download here, and then you're gonna choose the Anaconda installer for your system, whether you have a Windows, a Mac OS, or a Linux. I'm on Mac OS, so I'm gonna go for this, and you're gonna take the graphic installer, not the command line installer. All right, so graphic installer, and you're gonna take the Python 3.7 version, not the Python 2.7, right? So only this row here. So choose your system, click the file, and this will download Anaconda, the installer. And in a few seconds, you'll get, the installer on your machine, probably in your download folder, which is done for me. Good. So let's just get rid of this, download. And now let's go to my machine. There we go. This is my download folder on which the installer was downloaded. So make sure to find it and then double click it. And this will launch the installation of Anaconda. Here you can just click continue, 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 continue. Just click agree and continue. You can read that if you want, and then install. Then this will install Anaconda. This will just take a few seconds, not more than 1 minute. And, okay, less than a minute. There we go. Good. So right now Anaconda is installing, and let me tell you a few words about Anaconda. So this is basically a platform that contains several IDEs on which you can code in Python and even R, because you will see that it contains now RStudio. But the Python IDEs that it contains include Jupyter Notebook and also Spider. Spider is another great IDE to code in Python, but here we're going to go with Jupyter Notebook because we have been used to, the IPYNB format, which was the format we used on Google Colab. But this time, since we have a huge data set which we can't import on Google Colab, well, we're going to run this with Jupyter Notebook. All right, so let's see where we are. So still installing, well, running the package scripts, but you will have Anaconda on your machine with no issue. All right, so here, this is just to give indeed access to your downloads folder. So of course you click OK, and then it should progress now. All right, let's see. And there we go. Perfect. So now we have Anaconda. You can click continue to end the installation. And yes, close. And then you can either choose to keep the installer or remove it as you want. I'll just keep it. All right, so good. Now we have Anaconda. Then it's not over. We still need to install a few things. And these things are, unfortunately, the TensorFlow library and the Keras library. Because I remind that the beauty of Google Colab and the reason why I wanted to code everything on Google Colab was that we didn't have anything to install because all the libraries and packages are already pre-installed except for the rare ones. But here on Jupyter Notebook or Spider or any Anaconda IDE, well, we have to install manually the packages, and that's exactly what I'm about to show you. So for Mac and Linux users, please open your terminal. Linux users, you'll find that very easily, and Mac users, well, you can just press Command plus space, and then in the Spotlight search you can type terminal, and this will open your terminal. And for Windows users, no worries, I'm not forgetting you. Windows users, please go, at the lower left corner of your monitor, please click that window button and then find Anaconda in your list of programs. And in the Anaconda tab, you will find command prompt. Then please click it, and this will be the equivalent of the terminal on which you can run commands to install packages from the web. All right, so now we should all be on the same page, Windows users, Mac users, or Linux users, and we're about to install TensorFlow and Keras. And you will see that it will be still super quick and easy because the simple commands that we have to enter here in order to install TensorFlow and Keras are the following. So we have to enter them separately. Let's start with TensorFlow. We simply need to enter pip, then install, and then TensorFlow. All right, and then we just need to press enter, and this will download TensorFlow from the web and install it on your Anaconda environment. All right, so right now, as you can see, it is downloading it and installing it. All right, so don't worry about all this. This is totally fine, right? See, installing collected packages, including indeed TensorFlow. So it is not only installing TensorFlow, but also some what we call dependencies which work with TensorFlow. But please don't worry about all this. This will just install TensorFlow, which is exactly what we need. Okay, good. So installation done. As we can see, successfully installed all these dependencies, including TensorFlow. And now to install Keras, well, we're going to do the same. We're going to enter pip and then install and then Keras and then press enter. And this will install Keras on your machine. There we go, successfully installed Keras, and that's the version that we just installed. You might get a different version if you take this course way after I recorded it. Good, done with the terminal, no worries, we won't have to deal with it anymore. I hope it wasn't too traumatizing for, those of you who used it for the first times. I know it can be a bit surprising at first, but indeed this is the classic way of installing packages when you're not working on Google Colab. So then you can quit the terminal, and then there we go. Now we're ready to finally open Anaconda and mostly open Jupyter Notebook. So we're going to find Anaconda in either, the list of applications for Mac users or in your list of programs for Windows users, and same for Linux users. So on Mac, here is Anaconda. So let's just double click it and this will open it. I can just go back to, my desktop here, because Anaconda is now opening, and in a second we should see that beautiful platform, very user-friendly, containing all the different IDEs on which you can code with Python. All right, loading applications, and in a second, there we go. Welcome to Anaconda. Good. So as I told you, you have several IDEs. You have this RStudio for R, but you have several of them for Python, including Jupyter Notebook and Spider. And as we said, we're going to run our implementation on Jupyter Notebook. So here we're going to click Launch. All right. And this will launch Jupyter Notebook, and this will automatically open it on a new tab on your browser. You'll see, we should see pop up in a second. There we go. So welcome to Jupyter Notebook. So this is your machine. You will recognize the folders of your machine. And of course, now you're going to go to the folder that contains, the data set, which you downloaded at the beginning of this practical activity. So remember, mine is on my desktop, and here is the folder, section 40, Convolutional Neural Networks. So we're going to click it, and inside, well, as you notice, I only kept the data set. I removed the two previous implementations which were in that folder, because now what I want to do is actually take our exact implementation we coded during this practical activity. I'm going to download it by clicking File here and then download.ipynb. Make sure to take ipynb because that's the format used for Jupyter Notebook. All right, then I'm going to close this, and now we're going to go to where this was downloaded, meaning in the downloads folder. We're going to put that into this folder, containing the data set right here. So you have to put it in the exact same folder. That's important because you have to run this file on Jupyter Notebook within the same directory folder that contains the data set. That's why it's important to do it. So this is the exact implementation we, coded together during the practical activity, and now we're going to check that it works by running each and every single one of the cells. So let's do this. Let's go back to Jupyter Notebook, which is right here. Okay, good. And now indeed we have, well, our implementation. Good. So let's open it by just clicking it. And welcome to our implementation of the convolutional neural network. And now is really the show time, because the only thing we'll have to do will be to click this run button cell after cell. Even the text cell, we'll just start from the beginning and see what happens. Okay, so are you ready? Let me just, clear all the outputs, which were the outputs we got in Google Colab. So to do this, we can click kernel here and then restart and clear output, right? We won't get these outputs. We will just really start from scratch. Okay, good. So now let's do this. 3, 2, 1, go. Run. Okay, so that doesn't run anything because this is a text cell. Run again. And now it is starting. So we're going to click our first run for the first cell. And this will import TensorFlow. This star means that it is running right now. The cell is running. And when it is done running, we will see the first number 1, meaning that the cell is successfully run. Okay, there we go. Using TensorFlow backend, that's the output of this cell. And in order for this to work this way, well, make sure to have run, like me, the pip install commands of TensorFlow and Keras. All right, good. Now let's check the version. It's still going to be, TensorFlow 2, 2.2.0. And then let's just run the rest of the cells. There we go. So now we're entering part 1, pre-processing the training set. And now running this cell, we will get in the output that indeed we imported and pre-processed, with data augmentation, 8,000 images belonging to 2 classes, dogs and cats. Okay, then let's click run for the next cell, pre-processing the test set. And now running this cell, we will get indeed, this time, 2,000 images belonging to 2 classes. And of course, no image augmentation was applied, only feature scaling was applied. All right, and now entering part 2, building the CNN. So there we go. First, we initialize the CNN as a sequence of layers. Then we start the first step, step 1 convolution, where we add a convolutional layer. Then pooling. Let me just scroll down a bit actually. Right. Then pooling. So here we apply max pooling to this first convolutional layer. Good, done. Then we add a second convolutional layer. And at the same time, we apply max pooling. Done. Then we proceed to step 3, where we flatten the results of all these convolutions and pooling into a one-dimensional single vector, which will become, in this new step 4 full connection, the input of a fully connected neural network, which will contain only one fully connected layer with this cell that we're about to run. Done. And now, let me scroll down a bit again, right? Let's scroll down like that. Okay. And now, in the final step of the construction process of our CNN, we will connect all these to the final output layer, which will contain the final prediction. Right? So let's run this cell. And there we go. Now we're done building the CNN. Everything looks good so far. We now have a brain with some eyes that are able to see images, just like we humans do with our eyes. And now that we have this brain and these eyes, well, time to make them smart by training the CNN to recognize cats and dogs in images. So there we go. We enter part 3 now. First, compiling the CNN with an Adam optimizer, which will perform stochastic gradient descent the best way. Then a binary cross entropy loss function, because we're doing binary classification, and an accuracy matrix. There we go. Now our CNN is compiled. And now, my friends, it's time for the training. Are you ready? This following cell will run the training for 25 epochs, and at the same time, we will get the accuracy on the test set. So this will be very exciting, because we will see the accuracy on both the training set and the test set getting increased and increased over time. Are you ready? I'm not going to make us wait longer. There we go. Now the training is starting. There we go with the first epoch, 1 of 25. And here you see the loss, the accuracy, progressing, increasing. So basically the 250 here corresponds to the fact that, the batch size is 32 and we have in total 8,000 images. So that, 32 times 250 equals 8,000. So basically, we have 32 images in the batch and we have 250 steps in each epoch to, reach the total amount of 8,000 images. All right, so first epoch done. Let's see what we got. We got an accuracy of 61% on the training set, be careful. And on the test set, we got an accuracy of 67.75%, which is pretty good. All right, and now the other epochs are running, but as you can see, it's going to take some time. So I'm just going to do a fast forward here with some exciting music so that we can observe and mostly admire the results and the progression of, getting higher and higher accuracies in accelerated mode. All right, are you ready? 3, 2, 1, action. All right, here I am back in the game. I'm super excited to see the final result here of the 25th epoch. There we go. We end up with a final accuracy on the training set of 89% and a final accuracy on the test set of 80%, which is great. And I remind that if we hadn't done the image augmentation preprocessing, in part 1, well, we would have ended up, you can try with an accuracy here of the training set around 98 or even 99%, which clearly indicates overfitting, and a lower accuracy here on the test set, around 70%. So that's why I insist image augmentation is absolutely fundamental. Okay, so the training is done. There you go, you had your first advanced training. Congratulations again. And now, well, let's test our model in production by, making that single prediction of a single image. All right, so just before we run this, let's just make sure we know what we're predicting. So we're going to go back to our folder, which is right here. We're going to go into our dataset. And remember, those single images are in the single prediction folder. And we're going to start with this one, CatOrDog1, which contains, of course, a dog. And now we're going to check that our CNN can predict that indeed there is a dog inside this image. Are you ready? Let's do this. Where is it? It's right here. All right, so play. Now we're first going to play the cell to, get the prediction. Make sure to have CatOrDog1 here, which corresponds to the image we just saw. And now let's play the cell. And now we're about to get the final prediction printed in the console. And we're certainly hoping to see dog in the output. Are you ready? 3, 2, 1, run. And perfect, our CNN predicted that there was a dog inside the image. Okay, good. First test passed successfully. Now let's see for the other image, this one, which contains, of course, a cat. So let's deploy our model on this single image and check that indeed our CNN returns a cat. So to do this, we just need to, replace this image name here by CatOrDog2. Then we can just play the cell again by just clicking run again. And now we're going to print this again to print the new prediction of this other image. So let's do this and let's hope that indeed we get cat in the output of the console. Perfect. So our CNN got all the answers correct. But what if I make it even more challenging? Because maybe I was sneaky and maybe I chose images in a test set that I checked was working well with our CNN, that our CNN was able to predict correctly. So to make it more challenging, my idea is to open a new tab here. Then in the search bar, I would like to generate random number. And we're going to generate a random number using this, the classic tool by Google. And we're going to generate a random number from our test set, which contains the new images on which the model wasn't trained. And we're going to take randomly an image from this test set and test it as a final test, for our CNN. So let's see. The images of the dogs in the test set go from 4001 to 5,000. And the cats go from same 4001 up to once again 5,000. Okay, so let's start with dog first. Let's generate a random number, between 4,000 and 5,000. And let's generate this, and we get 4689. Okay, so let's get that image. 4689, which is a bit below, okay, right here. 4689. All right, so that's actually going to be quite challenging. Our CNN might not recognize that it is a dog, but let's see. So I'm going to take that image, I just copied it, and into the single prediction folder, I'm pasting it, and I'm going to rename this, I'm going to rename this Catodog 3. All right, so that will be our third image. And now let's generate a new number for the cat. All right, 4,538. And so in the test set, let's go into the cat folder and let's take, what is it again? 4,538, yes, 4,538, which is right here. All right, whoa, it's gonna be challenging again. Let's see. We only see a cat head here, so let's see. Okay, wow. I didn't expect such a hard challenge, but let's see how our CNN is going to do anyway. So I just copied it, and into the single prediction folder, let's paste it. Let's, copy the name of this, and then paste that here to replace that by Catodog 4. All right, so let's deploy our model on this single image first, and let's hope that, it predicts this time a dog. So here it is, Catodog 3. I'm scared. And let's play run and then print prediction. Dog, woohoo, great. I was really scared because, it's not that obvious for a machine that the dog in the image is a dog, but that's really good. Okay, and now that special cat in this red gift wrapping thing, Catodog 4, let's hope that our model recognizes that it is a cat. It's obvious for us humans, but here we only see a head actually, with the features of a cat. So yeah, let's hope that it will work. So Catodog 4, and now let's play the cell. I'm scared again. And, excellent. So 100% correct answers from our CNN. So that's awesome. I'm really happy that it worked 100%. That's because, we have, after all, an accuracy of 80% on the test set. So which means that indeed, 8 predictions will be correct out of 10. So yes, even if the images are quite challenging, with not some obvious dogs or cats, well, our model can do pretty well. So congratulations, you just built a pretty advanced artificial neural network. The convolutional neural network is quite technically advanced. So congratulations, and not only you built it, but mostly you built it successfully. It is now a really good cat or dog predictor. And feel free to, play the same game by generating a random number and test some other single images. You might be surprised by, the predictive power of the model you just built. All right, so we're making great progress here. Now we're done with the deep learning part. So we're going to move on to the next part, which is about dimensionality reduction, and which is super important for you and your career because you're going to work with huge data sets with many, many features. So you need to have the right tools in order to reduce the dimensionality of your data set without losing, of course, the information. The information that allows to learn some correlations between the features and the dependent variable. So that's a super important chapter. I'll look forward to seeing you in this next part. And until then, enjoy machine learning.